Good morning. This lesson is from our Trig-Precalc class, but before I get started, I want to say I hope that everyone is doing all right out there. This is for Chapter 4, Lesson 4. Let's go ahead and jump right in and read our goals. So our first goal today is to find side lengths of right triangles using trig ratios, and our second goal is to solve a triangle. Let me just quickly review with you guys really quick what the trig functions are. The sine of an angle is the opposite length over the hypotenuse. The cosine of an angle is the adjacent length over the hypotenuse, and the tangent of an angle is the opposite length over the adjacent length. And we want to figure out which of these ratios you have, and then we plug that into the equation. All right, so I have two examples I'd like to work out with you guys here really quick. I'd like us to find solve for the unknown variable. I want to know the hypotenuse length here, and I want to know the adjacent length, right? So this trig function is going to be the sine function because I have an opposite length to the angle I know, and I want to find the hypotenuse. So I'm going to set this up. I get sine of 24, and that's equal to 8, which is the opposite length, over h. Okay. Now, you might think that sine of 24 is an unknown value, but this has a value. At an angle, there's a y-coordinate. So we could actually plug this into the calculator right now and get a value. This is the unknown value, not the sine, but the h. So let's get rid of the fraction, and we'll do that by multiplying everyone by the denominator. So this side gets an h, and this side gets an h. These cancel each other out. And I'm now left with h times the sine of 24 degrees. And that's equal to 8. I need to get h by itself, and sine of 24 is a number that's attached by multiplication. So I'm going to divide both sides by sine of 24 degrees. And I've now isolated the value of h, and h is equal to 8 divided by sine of 24 degrees. Now let me talk, I know that the answer has to be bigger than 8. I know that I'm going to get a value larger than 8. And here's how I know that. Sine of 24 is a number between 0 and 1. It's a small spoon. And remember, when we have a small spoon, we scoop more. So this is going to take more scoops. I don't know exactly what it's going to be. I'm not that good at calculating, but I do know that it's going to give me a number larger than 8. So let's see here. 8 divided by sine of 24. Make sure your calculator is in degrees, not radians. Enter. The length of the hypotenuse is 19.7. Roughly 19.7. And I do want to point out, in this problem, the unknown was in the denominator. Okay, let's move on to the next example. I have my angle here that I know. I have a length next to it, and I have the hypotenuse. So that means I have cosine, and I'm going to cosine, and let's plug in what we can and figure out what we don't know. So I have cosine of 36 degrees. And that's equal to the adjacent length divided by the hypotenuse. All right, this one's really easy to solve. I just multiply everybody by 14. Get the a by itself. So I'll multiply the right side by 14, and I'll multiply the left side by 14. All right, these will cancel out, and now I'm left with the length of a is equal to 14 times cosine of 36. Okay, and let me type this into the calculator. Now, I know without doing any calculation that when I multiply by a small spoon number, I have to make it smaller. So it's going to get to be a smaller value than 14. So 14 times cosine of 36, that is 11.3. So the length of A is 11.3. I'm having a hard time here. I'm trying to think and nothing happens. What did I say it was? I got so confused by taking off the cap. 11.3. I'm rounding to the nearest hundredth. But again, like I said, you just have to figure out which trig ratio you have and plug in what you can into that equation and then solve. So we're going to have to eliminate a fraction and then try to isolate the unknown variable. Sometimes it's isolated after the first step. Sometimes it'll be isolated after you multiply and then divide. All right, I'm going to go ahead and check off the first goal here. And let's move on to the second goal. And our second goal is about solving a triangle, and that means to find all the unknown side lengths and the angle measures. We want to use trig to find the side lengths. We want to use a triangle sum to find the angle measures, and three angles of any triangle add to 180. We use inverse functions to find angles, and we use regular trig functions to find length. I'm on purpose leaving out a potential problem. All right, I'm doing that on purpose, but if you did the homework for lesson 3, you should be able to do it. All right, so here we go. Well, I know that I'm at this angle, so I have an unknown opposite, and I have an unknown hypotenuse. Okay, so I'm going to stay at this angle while I work this one out. So I can say now I have this, well, here's something else I just realized. You only want equations with one unknown. Let me show you. Maybe you just start plugging in it and seeing what you get. So you could get the equation of sine of 23, that's equal to the opposite length, which is unknown, divided by h. You could say cosine of 23, and that's equal to the adjacent length, which is 12, and that's divided by h. Or you could say the tangent of 23, and that's equal to the opposite. And I probably should make this into, I don't know, it's not a 0, it's an O. So it's the opposite length divided by the adjacent length, which is 12. This equation is good, it has one unknown, the h. This equation is good, it has one unknown, the opposite length. But this equation is no good because I have two unknowns. I have an opposite unknown and I have a hypotenuse unknown. We can't solve it. All right, so this equation we solve will find us our hypotenuse length, and this equation, when we solve it, it'll find us our opposite length. So we can calculate that real quick. And then we also have to find this unknown angle. Remember, the three angles add up to 180. I got 90, I got 23 more, that takes me to 113. I think that means that I need another 67 to get to 180. All right, so let's look at the previous problems we did, and maybe we can pick up a last step here and just solve it real quickly. So I see a problem that has an unknown in the denominator, and it looks like the unknown is going to be equal to the known length divided by the sine function, or the trig function. And that would be true because I'd multiply both sides by h and then divide by cosine 23. So that means that h is going to be equal to 12 divided by cosine of 23. And here my unknown is up top, which is just like this problem. And the way that's going to end up is the unknown value is equal to the trig function times the known value. So if I were to multiply both sides by 12, we would get the opposite length is equal to 12 times tangent of 23. And we plug these into our calculator and we get our answers. And again, I think it would be a really good idea for you to just make sure that you're getting the same answers I'm getting on your phone so that you have it set up correctly. So 12 divided by cosine of 23, that is 13 for my hypotenuse length. And 12 times tangent of 23, That is my opposite length, and that's at 5.1. So this is the second half of the assignment. Oh, I wrote it down. 5.1. Oh, that's where I wrote it. So 13. I'm having a tough time today. All right. So we have solved this triangle. I have found all the unknown sine lengths and angle measures. And again, make sure you pay attention if you have to find angles that you can't use this. Then you have to use the inverse trig function. So I'm going to go ahead and end this lesson here. But remember, we found lengths of, on right triangles using trig ratios. And we can also solve a triangle, which means we find everything. So again, I hope everyone's doing all right out there. Have a good day, everybody. I'll see you later. Bye-bye.